We talked about outliers, leverage, and influence in simple linear regression, and as promised, we're revisiting it in multiple regression. So in multiple regression, a case can be extraordinary by having an unusual y value compared to the model, so a high residual, an outstanding x value for one of the predictors, or an unusual combination of x values. We had this table already from simple linear regression, so the same one holds here. We're going to look at the leverages called HI, and we're going to look at moderately unusual and very unusual leverages and standardized and studentized residuals and Cook's distances. So for leverage, anything above 2 times the number of predictors plus 1 divided by n, or 3 times the number of predictors plus 1 divided by n. The standardized and studentized residuals beyond 2 or 3, and standard deviations and Cook's distances above a half and above 1. In simple regression, leverage was easy to see if a value has a high leverage because it's far from the mean of the x values in a scatter plot. But in multiple regression with k predictors, a point might not be far from any of the x means and yet still exert large leverage because it has an unusual combination of predictor values. So we're working with our roller coaster data again, and this time we're going to predict speed from height and drop. Notice that both height and drop are significant. They have small p-values, and the r-squared seems high. About 86% of the variability in speed is explained by using height and drop in this model. So let's look at leverage. Our calculation yields that a moderate leverage would be 2 times the number of predictors plus 1 divided by the sample size. The number of predictors here is 2 because we had height and drop. So that's 2 times 3 in the numerator, and then our sample size was 76. It says that in the Excel output, but also I'm just telling you that. And this yields 0.079. And then the same calculation, just substituting in a 3 instead of a 2, is 0.118. So a high leverage would be anything beyond 0.118. So I've included the top 9 leverages in my output, and I actually used a program called Minitab to compute these leverages. I've included those in the table on the top left of your screen, and also a histogram of all the leverages. So we can see from the table that there are 7 leverages above 0.079, and there are 2 above the higher threshold of 0.118. But one in particular is very extreme when looking at the distribution, and that's our top leverage of 0.24. It turns out this is England's oblivion, and it stands out among the other leverages, so we need to investigate this. Well, it turns out that oblivion drops into a hole in the ground. So I've included some pictures that I found on the internet of oblivion. The height for oblivion is only 65 feet, and the drop is actually further than the height. Since it drops into the ground, it's 180 feet. So it has high leverage. It has an unusual combination of the predictor variables height and drop. So oblivion's leverage should make us think about conducting further regression analyses, one without oblivion. The more complex the regression model, the more important it is to look for high leverage cases and their effects. We're going to table that leverage for a moment and go on and talk about standardized and studentized residuals and Cook's distances and revisit it in a minute. So remember, we already learned this in simple linear regression, but a standardized residual is the residual, the vertical distance up or down to the line from a y to the predicted value y hat, divided by the standard error of the regression times the square root of 1 minus the leverage. And a studentized residual, or a deleted t residual, is where the same calculation, but this time the standard error of the regression is computed without the point that we're looking at, the ith point. We don't include that when we fit the model, and we compute the standard error of the regression that way. So the idea is, if this might be an extreme value in the residuals, we should see if it's extreme based upon the residuals from the rest of the model. And again, standardized and studentized residuals follow a t-distribution, so residuals beyond plus or minus 2 standard deviations and plus or minus 3 standard deviations are considered moderately and highly extreme. So I computed this regression in a program called Minitab and asked for it to give me all of the leverage, residual, and the Cook's distances. So here I've included the deleted t residuals. Minitab calls it t-res at the top of the column there. And I have just included the top 10 or so after I sorted my output. And so you'll notice that my top 3 studentized residuals they're all above 3, so beyond 3 standard deviations is very, very extreme. And pay attention to the names of these roller coasters, the Accelerator, Hypersonic, XLC, and Volcano. We'll be talking about those in just a minute. And notice that Oblivion, even though it had really high leverage, does not have a particularly large studentized residual. It's just 1, so very common. We'll revisit that in a second too. Now, a case with both high leverage and a large studentized residual is likely to change the regression model substantially all by itself. And so remember, we learned this before, an influential observation is one that if you removed it would change the model. So these need particular attention. We are learning about Cook's distances. There are also other measures. Another popular one is DF fits, but we're focusing on Cook's distance. This one is also included in many statistical software programs. And if you'll recall, we had some numerical cutoffs of 1/2 and 1. So if it's above 1/2, suspect influence. If it's greater than 1, strongly suspect influence. But if you look at like a histogram of the Cook's distances and you see that it's extreme compared to the rest of the distribution, then you can conclude that your observation is almost certainly influential. So I got the Cook's distances when I ran this regression in that program called Minitab, and I have included a table with the top 4 Cook's distances at the top of your screen. I've also included a histogram of all the Cook's distances from all the roller coasters in this data set. And you'll see that none of the distances, Cook's D, is above 0.5 or 1, but we do see in the histogram that there are a few that are extreme in the distribution of distances. So these should be investigated. So we already understood Oblivion's outstanding status. Most of the drop is underground and doesn't contribute to height. And the other 3 roller coasters, so we've already looked at Oblivion because it had a high leverage. The other 3 roller coasters were the ones I told you to pay attention to a minute ago, Accelerator, Volcano, and Hypersonic XLC. It turns out that these 3 are mechanically accelerated. They're not simply gravity driven. So I went ahead and included a table with the studentized residual, the leverage, and the Cook's distance. So you can see the top 2 here, Accelerator and Volcano. These are top 2 in terms of Cook's distances. Also have really high studentized residuals and kind of moderately high leverages. So these we definitely want to look at as being influential. They were very extreme in the distribution of Cook's distances as well. Oblivion does not have a particularly high studentized residual. It has a very high leverage, but it doesn't have an extremely high Cook's distance. Hypersonic XLC has about the same Cook's distance as Oblivion, has a very high studentized residual, and because it fits with the other coasters in terms of being accelerated, mechanically accelerated, we're going to group these 3 together. And I just wanted to point out that these were the 3 with the very high studentized residuals. So we're going to, if we were thinking about taking out Accelerator and Volcano and looking at those separately, we're going to go ahead and take out Hypersonic with them to look at it separately because it is also a mechanically accelerated roller coaster. And it does have a really high studentized residual, and it kind of looked a little bit extreme in the Cook's distances. So we ran the analysis again without the 3 accelerator roller coasters, and it had a striking effect. If you'll notice, height is no longer important in the model. The p-value is 0.292. So yet again, we can run another model and take out height since it wasn't significant. And this is again without the 3 mechanically accelerated roller coasters. So we just have drop predicting speed. And we see now that we still have a very high R squared, 92%, and things are looking good. So that data set has simplified a whole bunch since we took out the 3 mechanically accelerated roller coasters. So what do you do with the influential cases? So we took them out temporarily to run our analysis. One strategy for these extraordinary cases is to construct an indicator variable that's 0 for all cases except the one we wish to isolate. So this is equivalent to omitting the case, but with two advantages. It makes clear to others which case is extraordinary, and the t-statistic for the indicator variable's coefficient tests whether the case is influential. So I wanted to show you how I created that indicator variable. So this is a snapshot of the data set, just a part of the data set. And I've included the 4 roller coasters that we've been talking about, Accelerator, Volcano, Oblivion, and Hypersonic, at the top. And to show you how we're creating the indicator variables. So the last 3 columns are where I created the indicator variables. Notice that for Accelerator, I gave it a 1 only for the row that has Accelerator in it, and 0s everywhere else. Volcano only gets a 1 for the row that's Volcano, 0 everywhere else, and same thing for Hypersonic. And I used this extra column to include 3 more predictors in my regression. So it was the regression, we ran the regression now with drop as my first predictor, and then the accelerator indicator variable, the volcano indicator variable, and hypersonic. And if you look at the p-values for the 3 blast coasters, those indicator variables, they are very small. So this indicates that the blast coasters don't fit with the other ones. And the coefficient for drop, notice, is the same as the model without the 3 blast coasters. So when both high leverage and large studentized residual cases are present, just keep in mind it's not responsible to report only the regression on all the data. Once you know that observations are being influential, you should compute and discuss regressions with such cases removed. You can discuss extraordinary cases individually if they offer insight. Lots of times I recommend that you run the regression with and without, or do the indicator variables.